So in this video, we're going to talk about trophic efficiency and ecological pyramids. So when I say trophic efficiency, that's basically talking about how much energy from one trophic level gets transferred to the next trophic level. So for example, primary producers, how much energy gets transferred from the primary producers to the primary consumers, and then from the primary consumers to the secondary consumers, and so on. So remember, you can only transfer what you've stored up in your lifetime, right? If I'm planning on eating a cheesecake tomorrow and gaining some serious fat from it, if I get eaten today, then it doesn't matter, right? It doesn't matter what your plans were. It's all about what you've stored up in your lifetime. So there are a couple of ways that you can display this kind of thing. You can have pyramids of production, and that basically is going to show you how much energy gets lost from one level to the next. And I actually have a pretty good picture of that here. So you can see here, this is showing how many joules of energy are in the primary producers level, and then going up to the primary consumers level, and so on and so on. But look at how that multiplicative loss works, right? So that kind of helps you to see why a food chain usually isn't more than 4 or 5 links long, because you kind of run out of energy at the top. Now, another thing that you can do is you can actually have what's called pyramids of production. And so there's basically 2 ways that it can look. So you can have one like this. Ooh, that's a good triangle. Or you can have one that looks a little bit wider like this, okay? And so each of these is just another level of the food chain. So what I want you to think about is which one of these would be, more efficient, okay? So think about it. This is showing biomass, which is going to be all the organisms in each level. So which one would be the most efficient at energy transfer? The answer would be this one right here. And the reason is because it narrows very, very slightly as it goes from one level to the next. So this is showing not a lot of loss from one level to the next, whereas this one over here, you're losing quite a bit from one level to the next. So this is a very inefficient one. This one over here would be very indicative of like a marine ecosystem. And this over here would be a lot more indicative of a terrestrial ecosystem. The reason I say that is because remember, we're wasting a lot of energy in terrestrial ecosystems staying warm. So we waste a lot of energy with that. Whereas marine ecosystems, they are mostly cold-blooded, and so they're not wasting a lot of energy. And we're going to talk about a couple of things at the end of this chapter also that help them to be more efficient. Okay, so that's biomass pyramids. In the next video, or actually we're going to do in this video, sorry, we're going to talk about how chemicals can cycle. This is a huge important thing in ecosystems, because if chemicals don't get cycled, then plants can't take them up, and then you're going to have big problems. So there's a whole bunch of different types of chemical cycles that we have. A lot of these you're actually familiar with, you just don't realize it yet probably. So this one is going to be the water cycle, right? So as you know, water evaporates from land and the ocean and lakes, goes up into the clouds, cools down, and then it causes precipitation. So that's the normal way that the water cycle works. What humans are doing is we're taking water and putting it in places that it normally wouldn't be, and so we're kind of screwing up the water cycle. Perfect examples would be having pools in Arizona. Probably not good for the water cycle. Another example would be clear-cutting rainforest, right? Because rainforests have their own little microclimates that do this all the time, but if you have them cut down, then obviously that's not going to go back up into the atmosphere, and it's going to change the water cycle. So that's the water cycle. The next one here is the carbon cycle. So in the carbon cycle, you've got carbon that's going to be taken up from the atmosphere in the form of carbon dioxide by photosynthesis. And then it's going to go into the atmosphere in a couple of ways. One is going to be cell respiration. So every time we're breathing out because we're doing cell respiration, that's going to get carbon into the atmosphere, but also burning fossil fuels and wood, right? So for a long time, before we started getting a little bit crazy as humans, everything was kind of balanced. We had photosynthesis happening, and then we had cell respiration happening. happening, and so it was kind of doing this nice cycle. What's happening now is we have a lot more burning of fossil fuels and wood, and we're also cutting down a lot of these photosynthesizers, so we're having a lot of CO2 building up in the atmosphere. So we're totally changing the carbon cycle, and that's a huge thing that's been in the news a lot. Then the next one is going to be the nitrogen cycle. And the nitrogen cycle is a little bit more involved. So nitrogen is naturally occurring in the atmosphere. Plants love nitrogen. That's why a lot of fertilizers are nitrogen based. But what happens is the way that it's going to get into the soil is some of it will get rained down from the atmosphere in rain. But another way, the more common way, is going to be from animal waste. So when animals urinate, there's a lot of nitrogen, and in their feces, there's a lot of nitrogen. However, it's usually in the form of ammonia. So what's going to happen is there's going to be special bacteria, and that bacteria is actually going to change the ammonia into ammonium. Then there's going to be nitrifying bacteria, and their job is to convert the ammonium into nitrites. And then the nitrites are going to get fixed into nitrates, which is here, and then the plants actually really like nitrates. So if you have a balance of plants and animals, you should have a perfect nitrogen cycle. However, what happens is when we are messing with our nitrogen cycle through fertilizer and stuff like that, we get a buildup of nitrogen. And a lot of that nitrogen actually goes back up into the atmosphere, and that can cause a lot of things like acid rain and those types of things. So the nitrogen cycle can get mixed up quite a bit, especially if you don't have enough plants in an area. Then you're going to have a lot of that nitrogen building up in the soil. So there's a lot of things that are a little bit out of whack with that. What we do as humans is we like to take nitrogen from the nitrogen cycle and put it in like a farm or something like that, right? And then we have to keep bringing it because it puts all that nitrogen into the fruits. Then we take the fruits and sell them somewhere else. So we're kind of disrupting that cycle. And then this is going to be the phosphate cycle here. And phosphates are going to be another important thing that are going to be in a lot of fertilizers because plants really like to take up phosphates. How phosphates actually end up into our ecosystems is going to be from weathering of rocks. So you've got rain that's running over rocks, and that's going to bring it in. And also when you have organisms dying, that's going to end up putting phosphates into the ecosystem. However, like I said, it's a good fertilizer ingredient, so we are taking it from one spot and putting it into another and causing problems with that. So those are going to be all of the cycles, and I have them all listed here and how they basically work. And now in the and one last thing that I wanted to mention is the decomposition rates. So your decomposers, remember, are going to be really important. Those bacteria, like the nitrifying bacteria, they are going to be very important in cycling stuff back so the plants can take them up and the whole cycle can happen again. So we really, really, really need those decomposers, and the amount of them and how fast they decompose is going to determine how fast chemicals can cycle through an ecosystem. Now in this last video, it gets a little bit depressing, but we'll end on a high note. We're going to talk about humans and our impact on the environment.